Hello everyone, my name is Vipra Joshi and I am an assistant professor in St. Andrews Institute of Technology and Management in Electrical Engineering Department. Today I am going to deliver a lecture on subject of control system engineering. In this video, we will discuss the block diagram element and block diagram reduction technique. This is Unit 2 topic of 6th semester in electrical engineering. What is block diagram? So, generally in a control system, it contains number of components. So, the function of each component can be represented with the diagram. This diagram is called block diagram. So, the block diagram is nothing is a pictorial representation of the component integrated in the control system and signal flow. So here we have having so many elements for the block diagram. Generally, three basic elements we have having for use the block diagram technique. Basically, three basic element we are used. First, block, second, summing point, and third is branch point. Coming to block, it is represented like this in a square or rectangular form. In this control system, whatever the signal you are passing, that signal will be passes. That signal will be passes by this block. Block is having some gain GS. So here the transfer function is indicated by GS. So we can say block is nothing but it just like a junction point. Here some input for this block and here some output for the block, and the gain of the block is multiply. So if we want to output CS for the block, we can multiply RS into GS. By this, if we calculate gain for the block, it is CS upon RS. According to block functionality, the signal is going to modify. If there is some signal and the gain is multiplied by this signal, by this the signal is multiplied. For example, if we have here a signal and here gain is G, so the output is A into G. Second is, if we have gain 1 over G, then the output is A over G. So we can say that according to the characteristic of the block, the signal going to modify. Now the next is summing point. The summing point is like this. It add two signal and combine the two signal. If there is some A signal is coming from here and B is coming from here, then the output will be here is A plus B. So, if you combine your signal by mode of subtraction, if we see here, we combined this signal by mode of addition. If we want to combine this by mode of subtraction, the output will be here is A minus B, because A signal is here and minus B signal is coming from here. The output will be A minus B, and this is called the mode of subtraction. And if the signal is A here and here is the sign of positive, not negative, then B is coming from here, then output will be here is A plus B. This is called the mode of addition. Now the third point is branch point. The third element is branch element. If a point, so we can say that it a point from which a signal will flow concurrently to the other block. It means we can say that here this is a branch point. If some signal is coming from here, it is same going to here. A multiply by G. So these three is very important element for the block diagram concept. Now the second point is block diagram reduction technique. So the question from here to arise, why we use block diagram techniques. In any control system, it is represented by block diagram. So if there is many component represented by the block diagram and you have to find out the transfer function, then you can reduce these diagrams. For this, you are using block diagram technique for reducing the block diagram. So by this we can find overall gain and transfer function for the system easily. But we need to follow some rules. These rules are called block diagram reduction technique. Block diagram reduction technique. Now the first rule is combining block which are in cascade or in parallel. If we see here, these blocks are in series and we can say in cascade, and these blocks are in parallel. If there is two blocks are in series, then the output we will get G1 into G2. It means you can multiply these two gain, because our intention is to get the same output by individual block or by multiple block. So if we see here some signal is A, then the output is here A into Z1. Here a signal is A and output is here A into G1. Then the output come by this block G2 block is A into G1 into G2. And if we see this, here is output is A, here also input is A, here also output is A into G1 into G2. So we can say here the output is same. And in parallel connection, the output is added G1 plus G2, because here is summing point, here is the output is G1 plus G2, and also here the output is G1 plus G2. The second is moving a summing point behind a block. So if we want to moving a summing point behind a block, it is necessary we after moving a summing point behind a block, here we multiply by this gain. If we see here, some signal x1 is here, so the output is some and x2 is here. So we can say the output after these, if we want to zoom it, here is x1 and x2, and the output is x1 plus minus x2 here. So after this block gain, the output will come G multiplied by x1 plus minus x2. So for this block, here if signal is x1, then output is here x1 into G, and after this it is a summing point, here is output is x1G plus minus G. So we can say that here is signal, we know that here is signal is x2, so by this we can get the same output. Now the third is moving summing point ahead of block. In this we if see here is x1, and after that here the output is x1 into G, and if there is a signal x2, then the output here is x1, then the output is here is x1G plus minus x2. So if we multiply, if here is also x1, okay, then here output is, if we multiply by 1 over G this x2 signal, we can get here x1 plus minus x2 over G, and after multiplying by this gain, here the output will come x1G plus minus x2. So in both condition the output will be same, and our intention is to get the same output. So this is the third rule of block diagram technique. Next rule is moving a pickoff, yeah, we can say takeoff point behind the block. If there is a signal x1 and also here a signal of x1, so the output is x1 into G. And if we convert it like this, here is signal is x1 and it is necessary our output will be x1 into z, and here we want to x1 signal. So if this x1 into g is going to input side, so if want to x1 here, then it is necessary it is multiplied by 1 over g. By this gain is cancelled, this gain, and we can get x1 signal. So here also we can get same takeoff point. And the last is moving a takeoff point ahead of block. If we want to this takeoff point ahead of block, for example, if there is a x1 signal and after that we can x1 into g. So here the output is going to input is also x1 into g. So here if there is a x1 and the output is x1 into g, so if we take this takeoff point ahead of block, then here if we want to the signal x1 into g, so we have to need to apply x1 signal. By this we can feed back same signal x1 into g from here and x1 into g from here. So these are the techniques for the block diagram. Now we can understand these techniques by an example. Find the transfer function of the following block diagram. This is block diagram and we have to need find its transfer function. Here is input rs and output is ys, and all the elements are connected like this. So firstly, if we see this figure, here we need to this point ahead of block or moving it ahead of block or after the block. So the first step is applying the rule of moving takeoff point ahead of block. If we moving this point here ahead of block, then we know that if we take ahead of block, here some gain is multiply. So we see that in this feedback h1 the gain is multiply g2 because we take this point ahead of g2 block. Now if we see, we can solve this block because here g2 and g3 are in series. So the output is g1 into g3. Okay, then here g2 block are in parallel. So if we eliminate this loop, we can get g4 plus g2 into g3. After that our block look like this. So here also we want to the B takeoff point moving behind the block. So if we take this point behind the block, here we can multiply by 1 over g as the rules of block diagram techniques. So we want to take this point behind this block. So this gain is multiplied by for the path of this point. So our answer is 1 over G4 plus G2 into G3. Now if we see this figure, there is also a loop, second loop. Now by the feedback loop topology, we know that here G over feedback transfer function equal to G over 1 plus G into H. So now there is a gain of G4 plus G2 G3 and the feedback signal is S2. So we know that G over 1 plus GH. After solving it, we can find the value for this loop is G4 plus G2 into G3 upon 1 plus H2 into G4 plus G2 into G3. By this step, we can see that here these two blocks are in series. So we know that in series both gain are multiply. So the output is G1 into G4 plus G2 G3 upon 1 plus H2 G4 plus G2 into G3. After that we can see here also a third loop. This is gain and this is feedback signal. So applying same formula, G over 1 plus GH, we can get the value of this loop is G1 into G4 plus G2 into G3 upon 1 plus G1 into G2 into H1 plus H2 into G4 plus G2 into G3. After that we can see here there is also a loop. Here this is the gain of the loop and this is the feedback for the loop. Here there is no feedback value. So if there is no feedback value, we put H equal to 1. If there is some value, we need this value to putting. If there is no, we put the H equal to 1. Feedback value is 1. So after solving it, the ratio of output upon input is also equal to, if we apply this for transfer function formula, G over 1 plus G into H, we can find the value is G1 into G4 plus G2 G3 upon 1 plus G1 G2 H1 plus H2 into G4 plus G2 G3 plus G1 into G4 plus G2 G3. So by the all reduction technique, we can get this complex block, we can reduce this complex block into a easy block and we can find transfer function easily here. It means the ratio of output to input. Thank you.